Let's have a look at the nth term formula. Very popular question. You'll be given some sort of sequence of numbers and you will be asked possibly to work out what is the nth term expression or the nth term formula for that sequence of numbers. Okay, let's have a look at number one. Here we go. Let's say you've got 3, 7, 11, 15 and so on. So you've got a sequence of numbers like so. I'm not asking you what comes next in the sequence, although they may do in a part A of a question. All I'm doing is asking you what is the formula for the nth term. Let me show you how to get it, and then if you're not quite sure what it is you're trying to actually find, after I've found it I'll explain a bit about what it means. To find out simply what the nth term formula is, you simply work out what the difference is between subsequent terms of the sequence. So to go from the first term to the second term, you add 4. You add 4, you add 4. As soon as you see this common add 4 pattern developing, then the nth term formula will be easy. The nth term will simply be equal to, if it's add 4, add 4, add 4, it starts 4n. The temptation is, for people who don't really know what they're doing, is just to say it's n plus 4. No, that's nonsense. It's not that. So plus 4 plus 4 plus 4, it begins 4n. If it was plus 7 plus 7 plus 7, it would begin 7n. If it was plus 10 plus 10 plus 10, it would begin 10n. Okay, now, if that formula is correct, whenever you put n equals 1 into that, it will work out to you the first term. If you put n equals 2 into that, it will work out the second term. So let's try it. If n is 1, you get 4 times 1, which is 4. But the first term is not 4, it's 3. So what I have to do is compensate. I have to subtract 1 to get the 3 that we need. Let me just check with the second one. So 4 times, if n is 2, the second term, n is 2. 4 times 2 is 8. Take away 1. The second term should be 7. It is. It's 7. So what you're ending up with is a formula that you can actually work out any term of the sequence you like. So if you wanted the 100th term of the sequence in the list, you just say 4 times 100, 400, take away 1, 399 would be the 100th term in the list. So the formula you're finding is a very useful formula for finding any term of the sequence. If you were using that formula, imagine what n equals 1 would give. It would be 1 plus 4 is 5, so the first term should be 5, but it's not, it's 3. So quite patently that's not the right formula. So if I give you another one here, let's say you had 7, and then you have 13, and then you have 19, and then you have 25, and so on. The nth term formula for that will be equal to, well, here you're adding 6, you're adding 6, you're adding 6. So very straightforward, you're adding 6 each time. So the nth term formula starts off 6n, not n plus 6, 6n. Now, we might need compensation. So what you say is, imagine, let's work out the first term. So let n equals 1. So you get 6 times 1, it's 6. But it's 7, so I need to compensate by this time adding 1. 6 times 1, add 1 gives 7. Let's try it for the second term. 6 times 2 is 12, add 1, 13, it works. 6 times 3 is 18, add 1, 19, it works. 6 times 4 is 24, add 1, 25, it works. There you go, there's the formula. So if I try another one, how about 1, 8, 15, 22, and so on. Nth term formula. Here we go. This time I'm adding 7, I'm adding 7, I'm adding 7. So it's very straightforward. It starts off 7n. Let n equals 1. 7 times 1 is 7. But it's 1, so that's too big. So I subtract 6. 7n take away 6 gives you the 1. And you could try it for all the other terms with n equals 2, 3, 4. And it will work. That's it. That's the end of the formula. So a very basic idea. Spot the pattern and then put down the right number of n's. You'll notice in each of these each of the sequences are increasing in value. 1, 8, 15, they're getting bigger each time. Sometimes this sort of thing happens, so I'll do a couple of examples where this happens. Number 4, you might have something like 16, 13, 10, 7 and so on. So we've got a sequence of numbers, but this time they're decreasing. Okay, we need to work out the nth term formula. Nth term will be equal to, well, that is going down by 3, so it's take away 3. And you'll see there's a pattern, take away 3 each time. So as soon as you see that common pattern, take away 3 each time, we know how to start off our nth term formula. Now, if it was add 3 each time, it would start off at 3n. If it's take 3 each time, it simply starts off with minus 3n. You can obviously see the connection with the minus 3 above. Now just do the same sort of thing. To find out the first term, you'd say minus 3 times 1. It should be minus 3. Well, it's not. It's 16. Right, so okay, minus 3. What do you have to do to minus 3 to turn it into 16? You have to add 19 to it. Minus 3, add 19 gives you 16. And that's it, that's the formula. Minus 3n plus 19. You could try n equals 2. Minus 3 times 2, you get minus 6. Minus 6, add 19, gives you 13. So it works. Okay, let's try another one of these decreasing ones. You might have 11, 9, 7, 5, and so on. The nth term formula would be, well, this time you're subtracting 2 each time. Nice common pattern going on. If it's minus 2, the nth term would be minus 2n. Minus 2n. Minus 2 times 1 gives you minus 2, but I want it to be 11. To change minus 2 into 11, you need to add 13. And so that's the compensation. And there you go, there's the formula. I'll do one more quickly. How about 52, 42, 32, 22, and so on. Okay, you can see it's take away 10, take away 10, take away 10. So therefore the nth term formula will be minus 10n. Okay, minus 10n. Minus 10 times 1 is minus 10. Minus 10, it needs to be plus 52. So to go from minus 10 to plus 52, you need to add 62. And there you go, there's the formula for the nth term. And it's as simple as that. It's the end of this video.